Hi and welcome to the video on tan graphs. This one will cover exercise 3.4 and a little bit of 3.5 in your textbook as well. Now I believe that you've had a look at tan graphs before and you've probably seen a lot of what I'm about to show you, but I guess I'll just kind of do a little bit of revision and also point you to a few things, a few new things as well. So in terms of the standard form, this is what we have, the same kind of graph with B, H and K. Sorry, an A at the front there as well. Now again, all of the dilations, reflections and translations are exactly the same. They all do the same kinds of things. It's just sometimes we call them different things for tan graphs. For example, the B here affects the period, or what we call the period. So this is, the dilation from the y-axis can also be communicated in a way that's talks about the period as well. It's not the same thing. The dilation and the period are not the same thing, but they are related to each other. Again, you can have reflections, in the x-axis, flipping them top to bottom, and reflection in the y-axis, flipping them left and right, and you can move them up and down and left and right. Now, when you move the h, it actually affects the asymptotes. So that's something that we need to kind of be aware of in the future. Now the period for a tan graph is actually pi on b, so it's a little bit different from sine and cos graphs, but yeah, that's the period. Now to work out the asymptotes, it's a little bit different. I mean, this is the big equation, 2n plus 1 times pi over 2b, when n is an element of z. An element of z just means n is whole numbers, positive and negative. So 0, negative 1, 1, negative 2, 2, and so on and so forth. Now, if you just want to find one of the asymptotes, then you can just use this formula here. You can just say pi over 2b. That'll find you one, and then you can find out the others by adding a period each time. But this is the full one. That's how to just find one of them. Now, essentially, a tan graph is sine divided by cos. So if we look at these graphs and we get the red one here, and we divide it by the blue one, we're going to get these values over here on the tan graph. Now, there's a couple of points, when you've got a pi on 2, which is, about here, pi on 2, which is up here, you'll actually have something divided by 0. And that's 1 divided by 0, and that's not possible. That's why we have these asymptotes that the calculator doesn't display, but are there. Okay, and my lines aren't very straight, but that is that's why we have an asymptote at x equals pi on 2, and x equals a period onto that, 3 pi on 2. Okay, and so on and so forth all the way through. Okay, now what I might do is I might just show you a couple of the different things that can happen. I get the assumptions that I'm making is that you kind of know what a tan graph looks like, and you're sort of confident in being able to sketch these. I usually draw the asymptotes first, and then I can draw, find the middle point, and then being this middle point here, and then draw the rest of the graph. But let's just have a look at a couple of transformations that can occur. If you have a half out here, so it's a dilation from the x-axis by a factor of a half. What that'll mean is that it's the same as every other graph. It just means that everything's, squashed into the x-axis by a half. So all of the y values have been halved. So it makes it a little bit fatter, I guess, if you look at it. But that's what happens. If I have x divided by 2, and remember that f of x is tan x, so f of x over 2 means replace x with x over 2. That's the dilation from by a factor of 2 from the y-axis. Now, the period is pi. Okay, see how those two things are not the same? The dilation from the y-axis by a factor of 2 and the period, it's not the same value, but they kind of communicate as the same sort of thing. What this will mean is that every x value has been multiplied by 2, so it means that everything's kind of spread out a bit, and rather than being at pi, the asymptote is now, at pi and 2, the asymptote is now at x equals pi. Okay, that's how to draw that kind of graph. Now, if you've got a reflection, In the x-axis, it just means that everything is, I guess, flipped from top to bottom, so it's different from what we had up there. Negative f of x is negative tan x, and if you've got tan of negative x, that's a reflection in the y-axis. That means that it will be a mirror image based on the y-axis here, and it will end up looking like a reflection in the x. Actually, these two things are exactly the same. Kind of like the hyperbole, it does the same sort of thing in that case. Okay, if we've got a translation, let's just say translation of, don't go too far, half units right, that would be x, f of x minus pi on 2. That means replace x with x minus pi on 2. Translation of half units right, it's probably easiest to see the asymptotes that are changed. So instead of being pi on 2, it's now x equals pi, and so on and so forth. Okay, so asymptotes are probably the easiest to find for this one. And for this one over here, we've got a translation down. This one's the hardest one to see actually, because sometimes we can't really tell what's going on. It just means that every y value has been moved down or up. In this case, it's down. But sometimes it's very difficult to see. The things that will affect most and the things that we'll look at are the x-intercepts, which we can have a look at another time. Okay, so that just gives you a few different transformations that can be applied to a tan graph. In the next video, I'll just have a go at drawing a couple of tan graphs, and then hopefully you can give it a go yourself. Thanks.